Have you ever wondered if it would be possible to land on the sun? The human race is certainly capable of some amazing things, but first of all, we should mention that there is no landing on the sun, since it's mostly made up of hydrogen gas and it has no solid surface. Besides this fact, there is also the scorching temperatures to deal with, not to mention the intense radiation, solar wind, and other energy particles that come from our star. To get people there on some kind of spaceship without melting, burning, or even self-destructing would take quite a lot of technology that we currently don't have. But that doesn't mean we can't send something close to the sun to study it. Scientists have been waiting for over 60 years for technology to advance enough so that we can get a closer look. That is where the Parker Solar Probe comes in. This remarkable probe was built with cutting-edge technology that is simply incredible, and it is currently racing towards Venus, where it will begin its orbit with the star. This mission to study the sun will be one of mankind's greatest achievements. The primary goal of the mission will trace how energy and heat move through the solar corona and to try to discover what accelerates solar wind and other solar energetic particles. The probe will also measure the sun's magnetic fields. The other interesting thing that scientists want to know is why the sun's surface temperature is far less than the corona around the sun. Scientists understand that it has something to do with the sun's magnetic field that connects the sun's surface to its outer atmosphere. It's a key mystery to understanding the sun and solar physics, and with the probe's help, we're about to figure it out. What we do know is that the sun is basically a big hydrogen gas fusion bomb, 93 million miles away from Earth, with a surface temperature of 5,600 degrees Celsius, which is 4,000 degrees higher than the melting point of steel. That's 7,232 degrees Fahrenheit, with a core temperature of 27 million degrees Fahrenheit. And if you weren't just sure how big the sun is, you could fit 1.3 million Earths inside it. It's big, it's hot, and getting anywhere close to it has been a serious challenge until now. The Parker Probe, named for Professor Emeritus Eugene Parker, who predicted the existence of solar wind decades ago, was recently launched on August 12, 2018, and will become the fastest man-made spacecraft ever. It will swoop into the sun's corona quickly and then back out while collecting data. Over a 7-year period, the probe will fly closer to the sun than any other spacecraft. It will gain the speed it needs using the gravity of Venus during 7 flybys over the course of 7 years. That will eventually bring the probe within 4 million miles of the sun's surface, on the same distance from the sun as the planet Mercury. Think of this maneuver like a gravity assist or a slingshot around the planet, and each time getting closer to the sun, and it's going to be traveling very fast. For the record, the current fastest spacecraft, defined by its heliocentric velocity, is held by Helios 2, as it was last seen moving away from the Earth at a speed of 221,232 miles per hour. But the Parker Probe, on its final orbit, will be hurtling around our star at an astounding 430,000 miles per hour. However, it's currently traveling at 38,000 miles per hour, which is less than 10% of its peak speed. But in the end, it will be going so fast that it will leave other spacecraft eating metaphorical dust. The spacecraft is supposed to go into its first orbit with the star on November 2018 and get closer to the sun on 24 different approaches, each one swinging it closer into the sun's atmosphere, or the sun's corona. The glowing halo of plasma extends about 5 million miles into outer space around the sun. It's a bit hard to see unless you're using a coronagraph or looking at the sun during a total solar eclipse. The probe will have to withstand incredible amounts of heat and radiation, but it will zip towards the sun to measure and gather data. The probe will also have to withstand being bombarded by tiny fast-moving particles, some of which will hit the spacecraft. To fix this problem, the Parker Probe is fitted with Kevlar blankets to protect itself from impacts. During the probe's close approach, the sun will appear 25 times wider to the probe than when it left the Earth, and it will also be 625 times brighter. We told you that the Parker Probe is moving really fast, but to give you a better idea, we'll explain that. You probably know that the closer things are in orbit around any object with mass, the faster it needs to travel with respect to the object in order to stay in orbit. If the object is going too slow, the gravity will pull the object towards it and, well, that would be the end of our Parker Probe. The Parker Solar Probe will end up reaching speeds of 125 miles per second. The circumference of the Earth is almost 25,000 miles in diameter. This means that if the Parker probe were in orbit around the Earth, it would make one full trip in just 3.3 minutes. To give you an idea of just how close the probe is going to get to the Sun, if our Earth was at one end of a yardstick and the Sun on the other, the Parker Solar Probe will come within 4 inches of the solar surface. You're probably wondering by now how something could survive such a close encounter with the Sun. After all, there are a lot of expensive and sensitive instruments aboard the probe. In order to grasp this, we need to understand the concept of heat versus temperature. We won't give a full lecture because that would take a few hours. But in space, temperature can be thousands of degrees without providing significant heat to a given object. Temperature measures how fast particles are moving, and heat measures the total amount of energy that they transfer. Particles in space might be moving fast with high temperature, but if there are very few of them, they won't transfer much heat energy. We know that space is mostly empty, and with that, there are few particles that can transfer energy to the probe. For example, the Sun's corona has an extremely high temperature, but very low density. If you are still confused, think about the difference between putting your hand in hot water versus putting your hand in a hot oven. But please, don't try this at home. In the oven, your hand can withstand the hot temperature a lot longer than in the water, where it's interacting with more particles. Even though the probe will be traveling through space with temperatures of several million degrees, the surface of the heat shield will only need to handle 2,500 degrees Fahrenheit. If you want to compare that temperature to something, volcanic eruptions can be between 1,300 and 2,200 degrees Fahrenheit. Of course, that is still very hot, and the probe needed a shield to protect it. To withstand all that heat and protect the solar probe's instruments, a shield known as a thermal protection system, or TPS for short, was used for the probe to protect it from melting. The shield is 8 feet in diameter and 4.5 inches thick, and will always be pointed directly at the Sun. One tiny problem or miscalculation, and the mission would be over in just seconds, without the shield stopping the heat. However, just a few inches past this shield, the spacecraft body will sit at a comfortable 85 degrees Fahrenheit. This special heat shield material was designed by the Johns Hopkins Applied Physics Laboratory and built by a company called Carbon Advanced Technologies, and took 10 years to develop. The material is a carbon composite foam, which is sandwiched between 2 carbon plates. On top of the TPS is a layer of aluminum oxide, which reflects light, and a layer of tungsten between the carbon and the aluminum, so it doesn't turn gray. Alongside this is also a water-powered cooling system. This is the same material that was used as the heat shield tiles for NASA's retired space shuttle. It dissipates heat so fast that you can actually pick up a piece that is glowing hot without burning yourself. But not all the instruments will be behind the TPS shield, and one of those is the Solar Probe Cup, or Faraday Cup, which is a sensor that is designed to measure the ion and electron fluxes and flow angles from solar wind. Unique and cutting-edge technologies were needed to create this thing, so it wouldn't melt. It uses sheets of titanium, zirconium, molybdenum, with a melting point of about 4,260 degrees Fahrenheit. The grids producing the electric field are made of tungsten that has a melting point of 6,192 degrees Fahrenheit. The wiring for this instrument is really special. Regular wire would simply melt. But the team who worked on the probe grew sapphire crystal tubes to suspend the wiring, and the wire itself is made from niobium. There are several other designs on the probe to keep it sheltered from the heat. Solar panels can open and close depending on how close to the Sun the probe is. The solar arrays are protected by a simple cooling system, using 2 radiators that keep the coolant from freezing. The probe is also equipped with what is called WISPR, or the Wide Field Imager for Solar Probe. It will provide the clearest yet glimpse of the solar wind from within the Sun's corona. Comprising 2 telescopes, WISPR sits behind the heat shield between 2 antennae from the field's instrument suite. WISPR was turned on in early September 2018 and took closed-door test images for calibration. On September 9th, WISPR's door was opened, allowing the instrument to take the first images during its journey to the Sun. The field's instrument suite aboard Parker Solar Probe will capture the scale and shape of electric and magnetic fields in the Sun's atmosphere. When the mission is over, the Parker Solar Probe will end up going out in style. Like Cassini plunged into Saturn's atmosphere, or the Magellan satellite became part of Venus, the Parker probe will eventually become part of the object that it went to study. Dr. Eugene Parker, for who the mission is named after, is 91 years old and hopes to see a lot of his theories proven. Interestingly enough, this is the very first NASA mission named after a living person. We have been able to measure solar wind happening near the Earth, but only after it had millions of miles to cool down and blur together. However, the very closest approach won't happen until 2024. Until then, there are sure to be a lot of answers, as well as a lot of new mysteries as humanity touches the sun. We hope you enjoyed this video. What do you think about the mission to the sun? What things would you like to discover? Let us know in the comments below. We want to thank you for watching.